Hello, my name is Aaron Hinkle and my partner is Megan Walker, and we modeled the horizontal oscillating engine. So the project overview, we picked this, was the one that looked most interesting for us to model, and created the parts for it. We then drafted each of those corresponding parts, created 4 subassemblies, and then drafted said subassemblies in both assembled and exploded views. We then merged them all into one final overall assembly and rendered the image.
Our team dynamics, we went for a very informal structure. No necessarily team roles, didn't really see a need to designate a lead considering there are 2 of us. So we decided to divide the parts equally for each member to make and draw them. And then the main time we met was to assemble the whole thing, write the report, and to make this wonderful presentation. So our parts, we decided, like I said, to split them. They don't look quite even right now because a couple of the parts needed to be broken down further, which we'll talk about later. But Aaron did the base frame, crank disc connection pin, the crankshaft bearing bush, the crankshaft, the cylinder lagging, the cylinder pivot bush, the piston rod big end, the piston rod, and the pivot shaft spring. I, on the other hand, worked on the crank disc, the cylinder front lid, the cylinder pivot shaft, the cylinder rear lid, the flywheel, the inlet-outlet pipe, the O-ring, the piston rod gland, the piston, the seal, and the wood base.
This is what our final rendered engine looked like. It looks pretty much almost identical to the documents that we were given. And then we're going to go break down each of the subassemblies into the following parts. So we had 4 subassemblies. The base, subassembly, the crank subassembly, the piston subassembly, and the cylinder subassembly.
So the base, obviously you can see the rendered picture of the base next to us. This consisted of the wood base, the base frame, bushings, both the crankshaft bearing and the cylinder pivot, and 2 M6x25 wood screws, and 2 inlet outlet pipes.
The purpose of this part is mainly to hold the other subassemblies in the correct position for operation of the steam engine, as well as to deliver steam to the cylinder.
The next part was the crank, or our crank subassembly. This consisted of the crankshaft, the crank disc connection pin, the crank disc, the flywheel, and a panhead screw. For this part, we had a couple interesting challenges, I guess you could call it. One that I dealt with our flywheel was, let's see, in the back there, you can barely see a screw. Well, that screw's hole was at an angle, about a 30-degree angle from, I think, vertical. And we found that we had the issues with trying to assemble things because of the way I initially made the hole, which then had to be remade later so that it actually had the threads that weren't specified in the initial drawings we were given.
The next subassembly we had was the piston subassembly, which consists of the piston itself, an O-ring, the piston rod big end, the piston rod, and an M6 nut.
On this one, a problem that I found was that the initial drawing I was given for the piston was that the O-ring was included in the drawing, which you learned that you had to separate the two, so I had to make a separate O-ring for it and then just assemble it in later.
And then the purpose of this subassembly is to convert the pressure that is provided by the steam into a translational motion. And then the final subassembly that we have is the cylinder subassembly. Consists of the cylinder front lid, the cylinder rear lid, the seal, the cylinder pivot shaft, the pivot shaft spring, the piston rod gland, the cylinder lagging, an M6 nut, and 8 M4 by 25 pan head screws. One thing that kind of was difficult for me was the spring. Originally, it was just modeled as a helix that was then used the slot function, or rather the rib function, to create. They use a circular cross section to wind out the spiral, but the lack of flat surfaces made it incredibly hard to assemble on the assembly. So what we wound up doing was making a longer version and then using the pocket tool to create two flat ends that were more easily constrained on the assembly. Additionally, although you can't really see it here, there are two large fillets underneath the cylinder lagging that are features of the cylinder. These were not labeled in the drawings, and then also there were two small pockets on the bottom of the cylinder that had fillets that were not labeled as well, and that kind of became a running theme for this project, was the lack of clear labeling, especially when it came to the fillets.
Even with all those issues, though, we managed to get our part together. It moves, or at least in the CATIA version, we can move it as it is supposed to move. We figured out how to overcome those little obstacles by making assumptions, such as we came up with a general rule of thumb for all our fillets and made them 1 millimeter in radius.
The edge fillets that were none of which were labeled or given any clear indication of what their size was. We just assumed them all to be 1 millimeter for lack of a better reason than it looked close to what was in the picture that was given us.
But overall, it was an interesting project. Learned some interesting things about CATIA, and it definitely gave us a better idea of how the assembling works for these parts. Learned that you definitely want to think about how you're going to assemble the parts when you're designing the drawings, because sometimes if you do it one way, you don't get the axis lines you need, and it makes it almost impossible to line up correctly.
Another thing that we kind of learned while doing this that would be helpful for our final project was the lack of a formal deliverable schedule kind of came back to bite us, as we had to rush at the last minute to get a lot of this project done. So that's one thing that we definitely would change going into the final project.
Indeed.
All right, thank you very much for the time giving this presentation, and goodbye.